Hi, this is Samir, and today I provide you with some fundamental information about particles. So let's assume a liquid inside of Effex. And we have a drop here illustrated and how Effex is modeling this drop using particles. In a real fluid, there are a gazillion of water molecules forming the actual liquid body. As it would take a tremendous amount of time to calculate these billion of molecules, Effex does a simplification and uses instead a few less particles to form the actual liquid body, as we can see in the above illustration. But it still remains as accurate as possible to convincingly model the liquid behavior. So let's take a look at an Effex particle and see how it works. An Effex particle is first of all a container because it doesn't do anything on its own actually. Just takes some values or has some properties. These properties could be three different types in Effex. First of all, a scalar value. Secondly, it could be a vector value, or it could be a state value, so either true or false. And in the very beginning, when the particle is generated, by default, it has two properties always. It has a position, which tells us where the particle is in space, and it has a velocity, so a vector value again, which tells us how fast and in which direction it moves. Furthermore, you can attach as many properties as you want. You can attach, for example, an age property that tells us how old this particle is, or any other property that you want to. And then you can use these properties inside the framework. For example, other nodes can read out these properties and do certain operations based on these information. There are already a lot of predefined properties that you can attach to a particle in Effex, but there are also custom properties, so properties that do not have a special purpose per se, but you can fill them with whatever information you want and then read them out later and do whatever you want with them. Alright, so now that we know what a particle is and how Effex is sometimes using it, let's just switch back to Cinema 4D and create some particles. We will be building the most simple simulation setup with particles. So let's go into the Effects menu and into the Particles submenu, detach it and create a particle group. Remember that the particle group is just a container holding the particles that we will be creating. This particle group has 4 subgroups for 4 different types of particles, but in this case we will be focusing on the liquid particles. So let's generate some, and we choose emitter, particle, and volume because we would like to create particles inside of a volume. Then we use the candidate button in the volume field to generate a volume. Double click here to go to the volume, and we also need a volume shape which we create via the candidate button again, a sphere in this case, and I just hide it. Then go back and choose the particle group we would like to emit into, the particle type we would like to create, which is liquid in this case, and we create some particle emission settings. Once we did that, we see that the particles have been generated into the particle group. In the emission settings, I changed the jitter value, which will align the particles uniformly. As the emitter is using a grid-based object, the volume, it will go through all the cells in the volume and place particles in each cell. The default particle emission density is 8 particles per cell. Now if we run the simulation, we will see that nothing happens yet. And if you have watched the Grids Fundamentals tutorial, you know that we have just placed particles inside our particle group container. So what we need is an advection. We go into the particle group for that, click on the advection button for the liquids, and it will create an advection node, a pop advection, particle operator. Go in here, we see our particles are already signed, and we can also see that the particle type we would like to advect are liquids. And here is our first problem. It is set to dynamics and ballistic. As we have no dynamics, we change it to ballistic. And now if we run the simulation, we know that we have a gravity of minus 9.81 So the advection node is the necessary part to make the particles being transported. But now let's check out how to create particle properties. In our emitter, we have the field particle properties to attach. So using the candidate button, we create an H property which gives each particle a lifetime. And double clicking on it, go in there, set the maximum H, which is 40 frames, and now plane simulation will show us that the particles die after 40 frames. And now if I wanted to show this H on the particle color, I go into the particle group and choose the H here in the property field, and I can set the maximum threshold here, which is 40, I know it. So it becomes darker the older it gets, or the nearer it gets to death, if you want to put it like that. But we can also create, for example, a velocity property, although it is a default property, so it's not necessary to be emitted also, but it has a nice property. If I set the default value here in the property, it doesn't do anything. But if I assign it to the emitter as well, it will overwrite the standard or default value of each particle and gives us an initial velocity that we can assign to the particles. And sometimes that's all you need if you want to put it in one direction. But there's of course also a more complex way. So to have more control, you can create a force emitter here in the particle group. Would generate a pop forces, which I put before the advection. So I just want the forces to be applied to the particles before they are transported. And in our forces object, we also have the particle group already set, and I'll set to liquids, and I create a vortex force here. Here I can set the intensity. And let's just play this to see the outcome of this. There you go, it's a vortex forming, well, pretty huge for now. So let's put this down. No gravity. I go back in my force, just rotate it. No, maybe I could lower this value, this intensity. And now, oh, here we go. That looks quite fine. So you can see that we can simply apply forces now to the ballistic motions of these particles. So that's the workflow in the Effex framework when working with particles. These were the particles fundamentals, and I hope it was helpful to build a ground truth here, how to work with particles in Effex, and hope you check out the upcoming tutorials as well. See you soon.